When we refactor our example class, the things that we're going to do in order to apply the dependency inversion principle are to extract the dependencies out into interfaces and then inject implementations of these interfaces into the order. As a side thing, we'll also reduce order's responsibilities by applying the single responsibility principle, but we're going to just gloss over that as that's a separate module in and of itself. Let's look back at our solution in our order object. The order object has a number of dependencies that we need to extract, and we're going to do this by applying the strategy pattern and using something called constructor injection. So in order to do constructor injection, the first thing we need is a constructor. So we'll add that. And we can take some of the things that are common throughout the entire class that are currently parameters on checkout and move these into our constructor's parameters as well. So for instance, we could say that our order requires a cart, and then we can turn that into a field that we can use elsewhere. Likewise, we could say that we always have to have payment details. So we'll add those as well and make that a field too. And then the next thing we need to do is take some of our dependencies and convert those into interfaces that we can inject. So the first one that we see here is notify customer. And so we can simply take this exact signature and make that our interface. So we're going to say that we have a void notify customer. And we'll come up here and we'll just create a new interface in the same class for now. And we'll call it I notify customer for now. And you see it takes a cart in order to do its work. If we look at this, we're going to see that the cart has the customer email, and pretty much it looks like everything else it needs is here. Now the notify customer implementation might need to take in an iLogger or something at some point, but for now we can do what we need with just this simple interface, I think. So once we have this interface, let's go ahead and create a derived type for it, and we'll just do this right here, and we'll call this a notify customer service. And of course we want to implement the members, and so we have a notify customer, and we really just want to take this whole method out of here and place it into here. And at that point we have this notify customer service that we could use. If we come back into our constructor, we can then pass in I notify customer and pass that in as well. And now it's just a matter of wiring up these fields so that they are using the fields instead. So if we come in here and change notify customer to be underscore notify customer dot, now that's going to go ahead and call our notify customer method on our interface, and we've eliminated the dependency within order on anything having to do with SMTP. Now we'll see in a moment how we can repeat this same process in order to pull out the dependency on the inventory system and the dependency on our charge card. So let's look at our class dependencies as they began with our order class, and you can see that the order class had strong dependencies on the payment details, the payment gateway, the inventory system. There's also, not shown here, dependency on the system.net classes that are doing SMTP stuff. Now I've gone ahead and done all this refactoring already inside of the loose coupling folder here, and you can download this code and go through this yourself. The online order is something that currently does the work of everything that you would expect for an online version of the order that needs to do notification as well as credit card processing and inventory reservation. In the single responsibility principle video, we looked at a couple of other alternatives to order. For instance, if it was a point of sale order, you might not need to do a notification service because the customer is standing there and they know that they made their purchase. But in this case, we're talking about online orders, and we identified these 4 fields that we wanted to pass, in addition to the cart, which is being passed in on the base class of order through its constructor. And finally, with each of these interfaces established, we also created default implementation. So the notification service looks like the one that I just showed you. And there's also a payment processor and a reservation service that are simply cut and pasted out of what was there previously. So looking at online order, we can see that the entire class is now only 36 lines of code, and it's very easy to follow. You can also see that the new keyword does not exist anywhere in here. This class now takes in all of its dependencies through its constructor, making it very easy for us to test the class through the use of fake implementations. So let's look at what the tests would look like. If we look at our first test here, where we want to send the total amount to the credit card processor, we want to verify that whatever the cart amount is actually what we're going to charge the user's credit card. So for this, we're going to create fake implementations of each of our dependencies. We have a fake payment processor, fake reservation service, fake notification service, and we have a cart with $5.05 in it. That's of payment type credit card. We create our order and check out. Once we check out, we want to check two things. We want to verify, first of all, that our payment processor was called at all, and then we want to verify that our payment processor had the correct amount passed into it, and we're going to compare that with the cart total amount. Now, our payment processor interface does not support was called or amount passed. If we go look at iPayment processor, we'll see that the only method it supports is process credit card. So where are these coming from? Well, the nice thing about our fake implementation is that we can do anything we want with it. So within our fake payment processor, we don't actually process any credit cards, but we do have a couple of fields that we want to be able to access. One of them called was called, one of them called amount passed. And using these, we're able to verify that this method was called and that the amount passed is the one that we expected. If we were interested in verifying the payment details, we could expose those here as well and then check for them in our test. Remember that the point of unit tests is not to verify that the full system works or to test whether or not the payment processor itself works. The point of the unit test on order.checkout, which is the method that we're testing, is to verify that checkout does what we expect it to do. What do we expect checkout to do in this case? Well, we want it to process the credit card with the correct amount. We want it to call our reservation service, and we want it to call our notification service. We want to know that it does these things, and perhaps that it does them under certain conditions and in a certain order, if necessary. And that's it. We don't want to have to test every little piece of the system just to test this one method. And that's what separating out the dependencies is allowing us to do, is to isolate the order.checkout method and be able to test just the content of this method without having to have actual implementations of all of its dependencies. If we look back at one of the original methods tests that we had a test here that said that it should not fail with no items, no credit card, but it should have notification. And if we run this, we see that we get this exact same behavior that we did before. So now let's look at the class dependencies on online order and compare them with what we had with order. We've broken away from having dependencies on many of the concrete classes that order had and replaced those with interfaces. So we now have dependencies on 3 interfaces: reservation, payment, and notification, as well as dependencies on still payment details, the cart, and the order. But those we're able to new up without any kind of external infrastructure requirements like web services, database, SMTP servers, etc. And so this still allows us to test our online order without having to use any of those extraneous bits of infrastructure. So just to review, the main change that we made is we went into online order, we identified the dependencies that it had, and created interfaces for those dependencies. We modeled those interfaces based on simply what this particular class needs. So the client is the one that dictated what these interfaces should be. And then we moved the implementation details that previously existed in this class into implementations of those interfaces. And this was pretty much just a straight cut and paste of the method that we had previously on order, we moved into now a notification service who currently has just one responsibility of sending this message to a customer. This makes this particular class very easy to test and very easy to follow because it's doing only one thing, and it cleans up our online order class considerably as well, so that it's much easier to follow and simpler too. The nice thing about this is that online order is now being very explicit about its dependencies. You know when you create an online order that you must have a cart, a payment details, a payment processor, a reservation service, and a notification service. If you don't have those things, you simply cannot create an online order. There's no default constructor for it. And so we are able to tell clients of the online order class exactly what dependencies it needs in order to function.